physical limits of magnetic materials dictate the engineering boundaries of modern flight control systems. At high temperatures, standard neodymium magnets undergo irreversible demagnetization. This failure occurs because neodymium experiences a rapid loss of intrinsic coercivity. Its magnetic resistance drops 90% between 20 degrees and 200 degrees Celsius. For aerospace actuators and missile guidance systems, samarium-cobalt alloys are metallurgically irreplaceable. The samarium-cobalt 17 phase retains 40% of its room temperature coercivity at 350 degrees Celsius. Alternative materials like alnico offer thermal stability but lack the magnetic energy density required for compact designs. This leaves defense systems entirely dependent on samarium-cobalt chemistry. The supply chain supporting samarium-cobalt metallurgy is highly consolidated and geopolitically vulnerable. China controls 91% of global samarium oxide separation capacity. This concentration creates an absolute bottleneck for raw material inputs. Downstream processing is similarly centralized, with Chinese facilities executing 85% of global magnet sintering. This monopoly extends to intermediate chemical processing. While raw cobalt mining is concentrated in Central Africa, China refines 72% of the global supply. The resulting supply chain contains multiple single points of failure. Western defense procurement remains highly vulnerable to export controls on these critical process materials. This vulnerability is compounded by the historical instability of cobalt markets. In 1978, the Shaba II invasion in Zaire disrupted over 50% of global cobalt mining capacity. Nominal cobalt prices spiked over 300% in response. Because samarium-cobalt magnets contain 50 to 60% cobalt by weight, manufacturing costs are highly sensitive to such disruptions. The 1978 shock forced Western militaries to ration cobalt-bearing alloys. Today, the defense sector faces a compounding risk. Modern aerospace systems are hostage to both Central African extraction and Chinese chemical refinement. This dual dependency represents a critical structural vulnerability for advanced munitions manufacturing.